Well, hi, good morning. Thanks so much for joining me in my shop for another round with this radio. So I'm really in the final stages of alignment. I kind of thought I was finished the last couple of videos, but no. I still have the long wave band, which at one point I thought was not functioning, but I now think it is functioning. So we'll certainly find out when I try to align it. And then after that is another emergent problem, which is very low AVC voltage. It seems to me it will only get up to about 5 volts, and really it should be going up to 15 volts, and I've seen this radio do that. So what exactly has happened that we now only get 5 volts out of it? I'm not quite sure. Maybe along the way we'll discover that, or if not, then I'm going to have to go hunting for why the AVC is so low. And by the way, I've measured the output right at the detector at 5 volts, so that suggests low output from the IF. And that suggests bad alignment of the IF. I don't know for sure, but we're just going to do the long wave alignment at this point. So I have a camera shot of the meter and the eye that we can take a look at. So we'll see what the eye is doing, and why don't we get this radio receiving. So it's been on for a little while, so it's warmed up, and just putting on my headphones here. Let's listen to it. It's a very pleasant, very boring hiss. And I'm going to tune it. We'll see if that gives any indication that it's receiving. Oh my gosh. Oh yeah. Okay, so I think that's my signal generator we hear there. Now I've got this set to, we can see it in this other camera shot. Setting it right on the 350 mark here. Oops. Stick my head way over here just to make absolutely sure. Okay, so we're on 350 now. What I'll do is I'll tune the signal generator up to 350, and hopefully we're going to hear it. Here we go. This is a fairly strong signal too. My earlier impressions were correct. Let me just make absolutely sure that in fact I don't have the signal generator connected. I have an antenna on here. Let's put the signal generator on. Okay, so well, that's good. Took the antenna off and things went quiet. Something's coming through. Now, let's see if I can get the signal generator connected here. Just about the worst operation of everything is clicking this in here. Stick my head back there. I don't like doing that. Okay. Signal generator is on. Let's see now if we can find this 350. Okay, we'll put up a little higher power so every radio in the world can pick this signal up. Not this one. Turn the radio volume up full. Okay, if there's any hint of it, we should hear it now. Pretty convincing. There's absolutely nothing there. The first thing I should do is I should make sure it's on the right band, because it isn't. I haven't changed the band. Okay, volume down. So this band is, so I've marked the AM band here so I can always get back to the AM band. And one pass. Okay, now we're on long wave. Now I'm wondering why the radio was so quiet before. Volume up. Now it's pretty quiet. So we're on the 350. We're on the long wave band. Got back to signal generator 1 step. Okay. Now's your chance, radio. Can you do 350? Not a hint. There's not a hint here. There's not a hint that this radio is working. Really. So let's go to the AM band. Just convince me that everything is working here. This is the AM band. Yeah. That's convincing. Go back to the long wave band. This is where I usually make the mistake. Yeah, not that way. This way. Okay, we're in the long wave band now. 350. Let's put it full blast. Not a thing. The radio is extremely quiet. Okay, so let's see. In the past, I've gone to clip things onto the antenna and I've clipped them onto the chassis by accident because it's so hard to see back here. There's no question. Okay, clipped onto the antenna. Well, this is a pretty good indication that nothing is getting through. Now, I think my signal generator, my signal tracer can operate at this low frequency quite nicely. So we have an opportunity here to trace the RF through the radio if we want. That's jumping ahead just a little bit. Or is it? So I'm suspicious that there's no local oscillator running in this radio right now. That's my suspicion. It's a very even output, even though you tune around. Even being kind of nothing. So I think what we'll try to do, we'll try to detect the detecting the local oscillator, and I'll use the SDR to do it here. Let me get that ready. Okay, so you're looking at the display, the spectrum display from my SDR radio, and you can see it's the number 350 at the top of the screen there. The red line is sitting on 350 kilocycles or kilohertz, and that's kind of where the signal generator was and all that. So with the radio tuned right now to 300 and actually it's 325 at the moment. Let's make it 350 here. I'm just going to turn the dial up to 350. Let me flip back to this other camera for a moment. You can see what I'm up to here. So this is the, barely see it, this is the input to the SDR radio. This is the what's plugged into that input, this little coil here. It's just on a cable. So it's just a little 2-turn coil here. And my plan is to plunge it into the radio where I'm pretty sure the local oscillator frequency can be picked up by this coil. And then with some luck we're going to see it on the SDR. If we see it, we know it's working. If we don't see it, we're not sure of anything. So let's see if we can see this or not. We'll go back to the SDR, and what I'll show you, the oscillator coils are here. So I'm going to be just doing that. I'm just going to stick that in there, and we'll see what happens. In fact, you know what? I'm going to stop and change my camera arrangement just a little bit, make this more interesting. Okay, I think I got everything under the sun on this camera shot, so we can see the B+ meter. I'm not using this actually right now, not B+, but AVC meter, which I'm not using. You can see this meter, you can see the eye, you can see the frequency we're operating at. You can see what I'm doing with this thing, and you can see the SDR, obviously. So let's see, 350 it's tuned to, 455 or 456 IF on top of that. That's 7, it's around 800 kilohertz. So I think if I stick this in the radio now, something will show up around 800 kilohertz. Let's see what happens. About here. Anything happen. I didn't see anything. So important thing to do is to tune the radio, and then the thing that's moving, there it is. It's come out from underneath that other line. So there's the local oscillator. Now we know the frequency of the local oscillator now. It's 850. So let's think about this. We want it down in the range of the radio, which is up to 350, 400, or something like that. So it has to be below 400 plus 456. It has to be below 850 to even react on this dial. And where was it? I kind of lost it here. Where did it go? Wow, it's just at 850. Seems like it's way out of whack. So what we'll do is we'll bring it down into what is the range of the receiver, I think. Let's try a nice even number. I'm terrible at doing these head calculations when the video's running. Terrible. So I'm going to try to set it to about 855 here. Looks like about 850. That's good enough. 750 rather. 750. So 750 minus 450 is 900. So I believe the radio is tuned to 900. On the dial, 900. That doesn't make any sense at all. What's happened in my head? Oh, yeah, have I not drank enough coffee yet this morning? Let's try that again. So local oscillator is at 750. I subtract 450 from 750. 300. The radio's tuned to, on the dial, about, I don't know, 250? I don't know what that is. Around 300. Okay. Let me put on the headphones and we'll send in a 300 kilohertz signal. Oh my gosh, that's just about where the generator is right now. Okay. Do we hear anything around here? There it is. Okay. We got a piece of it. We got a piece of it. Right on 300. Excellent. The pointer is pointing at, looks like 250 instead of 300. 300 is up here. There's a chance of misalignment on, it's probably a much, you know what, there may be no chance of aligning on the image. There's no image at this low frequency. I think that's probably the case. So this is it. The first thing I'm going to do is try to lift it up on the assumption that the RF coils are way out. So right away we're going to jump in there. Oh my gosh, look what I have to do here. I can move this all around. I think we need to keep an eye on too much of that other stuff right now. Let me move this over here. Okay. So the adjustments I got to get at, you can see them. They're back in here, and they're accessed up through these screws, up through these holes here. Isn't that scary? That's scary all around. So I'm going to get non-conductive tools here to do this, provided I can find them. Okay, so the non-conductive part will be bumping into the panel here. Okay, so the first RF one is up this way. I'm just looking for a big boost in the signal. Wow, there's nothing happening here. That's not a good sign at all. Now this next one. Just checking because there's high voltage. There's 120 volts right in this area here. I don't want to mess with that. I think once again I'm finding out there's something wrong with this band. Okay, here's the other screw. Got quieter. So there's something going on. Something happening here. I'm I'm putting in a whopping signal into this radio right now, and it's barely getting it. So something's gone wrong here. We don't need the SDR anymore. I'm going to stop for a moment, clean up my screens, and we'll do some signal tracing at this point. Okay, here we go. First I'm going to cut the volume off from the radio. We're not listening to that. If we do hear any radio-ish sounds, it's going to be coming out of the speaker on this. This is basically a radio. It's a radio receiver. Does not have any intermediate frequency type stages in it. It's a TRF radio, if that means anything to anybody. And this is its very high impedance probe. And this is the ground connection here. So what we're basically going to do is just start at the antenna and follow the signal through the radio as best we can and see if it doesn't die off suddenly, or make sure it's even on the antenna. Maybe I've got something wrong in my setup here once again. It's always possible. Okay, so the magic eyes come on here. I'm going to attach the ground. Let's just listen. Everything's normal. So this, I want this set to the frequency that we are sending into the radio, which is 300 kilohertz. So first of all, we want to be on RF. Just set this here. RF. We want to be on band A. Band A, and we want to go down to 300. So here's 300. A little bit of volume on that. Now that's coming from the speaker in here. Radio receiver. So now where can I easily get at the antenna without craning my neck all crazy in here? Jeepers creepers. Nowhere. Man, I gotta reach around and touch it. Because this radio has a sub chassis up here, a lot of the very front end parts are really recessed up high and inaccessible. So I go all the way up in there. I don't think I want to do that. I got to reach around the back. Son of a gun. I don't want to do that either. So I'm going to bring a clip lead around the front from the antenna clip. This is basically the signal generator output. Okay. There we go. I've got a capacitor in series with the signal generator output. I wonder if that's cutting the signal way off. Well, we'll find out with this pretty quick. Let me clip it somewhere. What's happening there? That was interesting. Heard something. Let me put my headphones on here. Oh, I don't need the headphones. We're not listening to the radio. We're listening to the signal tracer. So what's happening here is I've got enough signal generator signal going through me to so amazing. Yeah, that's an interesting demonstration. If I put the signal generator signal into me, I can convey it. Without putting the signal generator into me, I'm still conveying a signal. That's what's in me. But I'm an untuned radio receiver. Absolutely true. So we're definitely going to pick this up now. Let me turn this down before we get our ears blown off. So we know the signal is here. I mean, look, I don't even have to touch it. Great. So we know the signal's there. Now, from there, it stays as RF all the way to the detector. I'm sorry, all the way to the mixer. The mixer tube is way up on top here. Oh, son of a gun. So we should listen to the grids of those two tubes. The first RF tube and then the grid of the mixer tube. I gotta reach around again. Okay, can I turn this at all? No, I cannot turn this at all at this point. Okay, so the first one I'm gonna tune to or touch is the 6K7. Probably don't even have to touch it, just get close to it. That was that, so it's definitely there. Now, the next tube, I'll turn this down because I think it's going to be a little loud. Next tube is the cap grid of the 6A8. That's where the RF antenna signal should be findable. Here we go. Oh. Nothing there. Back on the other one. Well, that's interesting. There appears to be no signal reaching the grid of the 6A8. Oh boy. Just on a whim here, let me put my headphones back on, turn the radio volume up. Oh my god, yeah, it's there. It's there, but it's weak, right? Weak is the problem. Weak is the problem. So it looks like it's weak on the grid of the 6A8 already. Weak on the grid of the 6A8. You know what that starts saying? Open coil. Open coil. I thought I reached an earlier conclusion that there was an open coil on both the shortwave, was here, and it turned out there was an open coil, and an open coil on the long wave, only because the long wave band didn't work just like the shortwave band. So I figured, well, what happened to short waves happened to long wave. This could really be the case. There could be another open coil here. So those signals are coming up on these coils. I should be able to pick it up. I should be able to pick it up. Right on these coils. Only they're back in a little bit. Okay, guarding your ears now. I'm gonna. So this would be the first set that should have that frequency on it, and then this set should have the same frequency on it. 300. 300. Double check here. 300. Well, contacting those coils back there, I don't know. Let's see what we can do here. Wow, there's lots of signal. There we go. Oh, I just stopped short of it. Wow, the other side here. That could have been a grounded terminal there I just touched. Well, there doesn't seem to be anything on this coil. Because this should be screaming. Should sound something like this. Yeah, it should have sounded like that. Just setting the attenuation level on this properly. Okay. So this now, the eye just closing. Under this signal strength, the eye just closes because of the way I have it set. So if I try to pick that signal up again in the radio, I mean, you already know that this is not going to show up anywhere near that. So again, I may have only touched the grounded terminal on that coil, and I may not have done what I thought I did. Okay, so let's try with something a little different here. Maybe I can get in there with a clip lead. I'm going to turn off the tone we're listening to from the radio because it's confusing. Now I'm going to try to just, you know what I can do here? This is really dumb, but it should work. I just clip this on the end of a screwdriver. I can reach in with the screwdriver. There's much better ways of doing this by using a bare shank screwdriver. Okay, down on my knees to get in there. Wait, just check the sound. That's what we're hoping to hear. Something like that. Now there's no high voltage in here, so that's why I'm willing to do this. That's one terminal of the capacitor. The other terminal is completely inaccessible. Come on. Oh my gosh. If I change bands, the antenna signal will, even though it's the wrong frequency, will still be presented to the coils. So if I change to the AM band, that same antenna signal should be presented to these coils, which are easily accessible. Let's look for it. Let's see if my theory's right. Nothing. 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 Nothing at all. Nothing at all. It's because that's not the right coils. There it is. Okay. We're getting somewhere now. How loud is that? So we can look over at the magic eye here and compare. So the eye is basically hardly changing. The signal at the antenna is that. So we wish there was some way I could contact the proper coil contact back there, but it's completely hidden. There's no way to get at it. So what do we got here? We got a suggestion. These coils are supposed to be essentially connected directly to the antenna via wire. There's no tube or anything in the way. Something's going on here. Let's go back to before I forget. Okay, we're back on the long wave band. Yeah. The only terminal I can touch, I believe, is the grounded side of the coil terminal. There's just no way. These trimmers are on the secondary side, are they not? So I think what we're discovering here is an open coil again. I think that's where we're ending up here. So we're filling around with, this is the antenna coils. Well, these are the antenna coils. So these coils, these middle ones, are after this tube. So we're up here, we're on these coils, which are just coming right off the antenna. The primary, the secondary is the tune side, so I'm trying to touch the secondary at either side of this little trimmer capacitor here. I'm getting nothing. And in fact, it's not here, it's up here. Anyway, it's up here. So there's a resistor in there. So what I really want to touch is the contacts on the primary. But what I'm really checking is the secondary side. If the transformer was working here, I would think I'd have no problem hearing that signal. If the secondary was open, I could probably, no, I won't say that. As you know, just getting the probe close to something is enough to pick up a signal. What if I just lay the probe up against these two coils? Hey, I can do that. I think I can do that. I can do that with this. Let's try it with this first. So $300. I should make sure this is tuned here. Yeah. Okay, laying up against the two coils, one of which is primary and the other is secondary, and I'd have to guess. I'm going to guess. I can hear it. So that's the secondary laying up and moving away. This is the primary. The way I would interpret that is open circuit in the primary. The primary is acting like an antenna. It's no longer a coil. It's no longer a transformer type coil. It's just an antenna wrapped around a form there with an open circuit in it. So it's just a piece of wire going nowhere. But that's still energized by the signal coming in. On the secondary side, it can't really hear any effect of getting closer and farther because the secondary is just getting nothing. And why is the secondary getting nothing? It's close. Because there's no magnetic type transformer action going on, because there's no current flowing in the primary, open primary coil. So it really should be able to pick up the signal. Well, we can pick it up by getting in proximity of the coil. And I was going to say we can just contact the wire coming to the coil. I'm not sure that would provide more evidence. I think the evidence is in. I think the evidence is in. So I think that's the end of the long wave. Again, there's nothing to receive on long wave, really. Really nothing. Some old ship navigation beacons that may be running in the Great Lakes. I don't know what else. Some other kind of secret spy stuff maybe, because it's secret. I don't know about it. You don't either. I don't know. I doubt it. I think there's nothing going on down there. And a ton of noise too. That also explains why this radio is so quiet on this band. It's essentially got no antenna connected to it. There's a break right in here. Okay, that's the end of that problem. That's the end of me. Now, the next one. What is going on with the magic eye? That it's not really so magic anymore. I had 15 volts of filament or grid voltage on it at one point. And I remember earlier on there came a time where the eye was popping open and closed. And my kind of hope and assumption was that was occurring because of the shorts I eventually found down here. But I didn't know it at the time. I just noticed that it was popping, popping, popping. Maybe what's happened is it's stuck in the low state. There's something in here that if I did something to it, it would pop back to full voltage. And that sounds like cold solder joint. That sounds like something you can poke and find. Something that's true on all bands. Yeah. Okay, let's take a run at this low AVC voltage. First thing, 6K7, what kind of grid potential are they expecting? Or what is the range of a proper grid potential on a 6K7? Remote cutoff, that's the kind of tube that you vary the bias on the grid, and it varies the gain of the tube. And on here, didn't say much of anything. You have to read all this words here. Typical operation maximums, plate, grid 3, grid number 2, grid number 1. Grid number 1, volt minus 3. Well, that's not very big. Plate resistance, so it doesn't really give a range of what you could do with that. Grid number 2 gives an input wattage, which I don't fully understand. Well, that didn't help. 15, a lot of AVC voltages go way up, much higher than I would have guessed, but and this one did generate a 15 volt AVC voltage at some point in its operation. Why don't we get this meter monitoring AVC the whole time we're doing this? So if something exciting happens, we all get to see it here. So let's see. Meter's ground connection's already made. We want this on a good AVC point, which would be output from the detector. Why don't we measure it right at the output of the detector, right on the plates? What voltage is developing there? I don't think we can get any better than that in terms of really knowing what is coming out of the IF, what is coming out of the rectified IF. So that's going to be right up on here. Now the radio's on, so there's very little voltage here. Right here, don't make a mistake. That's the spot. Wow, didn't get a shock. Still alive. Still alive. Yeah, okay. So we're on the 15 volt scale, and the meter, you can't even see it. It's just lifted ever so slightly off of 0. So I'm on the negative setting here, so an upscale is actually a negative voltage. So that's, so we just have this to keep an eye on now. Probably a good thing to do is to review how effective this is using an AM, using a broadcast band signal, because we know the radio works reasonably well on, yeah, through all this, the radio continues to operate despite my best attempts. Let me turn the volume up here. Okay, we'll go to the AM band. Right here. Now what we're hoping to see is, as I tune around, variations on that AVC meter. So 15 volts is all the way over. Tune down. Oh, there goes it. Hey, look at that. Well, that's interesting, isn't it? Why is this guy reacting so strongly to this signal? Hertz. Still, it's still 300. Why am I getting this guy? So the signal generator is just blasting a signal. I'm just going to turn it down here. I'll continue looking for just a regular AM radio signal here. No antenna connected. Fat chance on that happening. So I really put the radio into fairly normal operation to make it a very careful observation that in fact it's not working. I'm trying to prove to myself this is not working. So right now the signal generator is the antenna, but so is this little piece of wire here. I can also cleverly bash in a signal. Maybe now we're going to get something here. Now this is not a particularly strong signal because you can hear all the noise all through it. Watch the meter here. It's not even making it to 2 volts. It's really nothing. So what I'm going to do, the signal generator is connected. I'm going to run a signal into the signal generator. We'll find out
when you have a plan,
which is stronger signal.
You can actually model the answer to that. If I continue to put into my RSPs, here's where I end up 20 years
So we're getting up to
if I stop and
not
focus
even,
on my
just over 1
paying off
volt.
the mortgage and
It's like nothing.
here's where
Get a quiet spot. There we are. Okay, so I'm going to tune the signal generator now to hit that quiet spot. Hit that quiet spot. It's up around 680. Signal generator is fairly low. Nice. Okay, now we're going to watch the AVC voltage. Now we're going to see what kind of signal it takes to make that AVC voltage get up in the normal range. Let me tune the radio into the signal properly. adding some noise here. Let me tune it back to the quiet area. I'll tune the signal generator to this quiet area. Wow, that's not... Well, okay, so we're on... Remember, full scale is what we would expect with a strong signal. This signal is not all that strong. Let's make it stronger. Okay, let's make it stronger. Monkey door even higher. Wow! So that's now 12. But I was putting one heck of a signal into the back of this radio. So the signal we have now, assuming my calibrated output from the signal generator, a bit of an assumption, would be 100 times 10 microvolts. So 1,000 microvolts a millivolt. We can't be sure of the volume again because of the way I'm doing this on this video. The volume you're hearing is, I have complete control on my soundboard. So, and the radio itself turned up pretty high. So I'll turn the radio up about 25%. Ignore the hum. Well, I don't know. Is that normal? That's not that bad, really. I mean, it is kind of bad. Sure. I just can't decide here. Well, the AVC is definitely working. I think... That's a big sigh. I have to convince myself the IF is tuned properly. And all the effort to do that, I booped it up somehow. The difficulty here is it's completely on the opposite side of the radio from where I'm standing. I cannot swing the radio around easily. Not without a whole bunch of adjustments here. So, yeah. Okay, so this is just a sensitivity check. I have to try reaching around. Oh, I don't know. Once I get the tool in place, my head will be in a position I can't see any instruments. Is that really true? I can still see this one. So I'm gonna come at this way. So we're gonna try the little IF can. Oh, I can't see anything I'm doing here. Oh my gosh. How am I gonna know anything here? This isn't gonna work. Look, I gotta make a big rearrangement. We're gonna explore the IF, but I gotta make a big rearrangement here. Okay, I think I've managed to get the kit and the caboodle on here all at once. So we can see the frequency we're sending in, we can see the audio level coming out, we can see the magic eye more or less. We can see the AVC voltage, and through the magic of video we can stop seeing all that. And you can see the 3 IF cans, I can see them fairly well too. So what I can't see is my adjuster tool. I'm going to go in with a stiff screwdriver again. Okay, just before we start, tune the radio and make sure it's maxed out. It's just too bad in that view you can't actually see the meters. So we'll tune the radio here. Fine tuning is very nice on this radio. So that's right on the money now. IF. Just going to twiddle it away. I'll be forced probably to do a proper alignment after I do this. That's probably what's going to happen. I'm going to wreck it out. But the question we have is this thing way out of whack? Is that why there's a low output? Shouldn't be. Okay, so watching this meter very carefully as I turn the screw looking for an upward movement in it, expecting downward. Down. Okay, the other way, up a little wee bit. sighted over. You know, this is not wise how I'm doing this either. So I'm not using the IF frequency. Let's go ahead. I'll just accept that I need to realign it afterwards. We have to find out if this IF has any juice in it that's not making it out. It's leaking its juice somewhere. Okay, here we go again. Down, down. This was right on the money. Small effect of the screwdriver, but it's just not enough to suggest any problem. I'm not going to find a problem here. This one. Down. And down. If anything, it was just slightly off. Again, I have to have a terrible mistake made when I did the alignment. And I didn't get it perfect, I'm sure, but wildly out? Can't imagine it. No, it's right on. Okay, we'll do the last can. First can, depending upon which way you count. Down. It's right on the money. Again, this is not the right way to do this, but for a sensitivity study like this, it's fine. And look again. All these are adjusted for maximum output. So how did we see 15 volts at one time? But you know what? I could have seen the 15 volts when I had the signal generator up really high. Maybe that's what's going on here. I've run the signal generator at a high level because I can't judge volumes in that properly. I don't really realize how high it is. Getting a pretty good looking AVC voltage. I think that's normal. Feed in a normal level antenna signal. Much lower. AVC much lower. And I'm convinced there's a problem there when there really isn't. Now there is a problem in that the eye will not close much. So what we're really trying to achieve here is to get the eye to close. You really need that 15 volts. The other possibility is the input to the IF string is low to begin with. So even though the IF string and its amplifier, all that's running well, how do I know it's running well? How do I know that that tube in the middle of the IF string is amplifying properly? Because I did tube tests on all these tubes. I'm going to refer to those tube tests now. Where are they? Okay, so here's my earlier tube test results. What you can see is the 6K7s, there's 3 of them in this radio. They all tested at 1500, and my tube tester expects a good 6K7 to test between 915 and 1450. It's actually 1500. Well, all 3 of these tubes tested really good. So that'd be the front end RF tube and the amplifier in the middle of the IF of the IF. Here's another one, 6K7 1400. They're all testing really good. 6A8 is testing a little low. 6A8 is a 2-part tube. So it's testing at 180. On the oscillator side should be 240. I don't think that, I mean, the radio's working. I don't think this tube is what? And you know, everything ahead of the IF should be suspicious. Should have suspicion. The 6Q7 tested low and I changed it, so it has a good 6Q7 in it. The rest of the tubes are original, I believe. Maybe not the 6J. Where'd it go? 6J7. That's well outside of the area we're concerned about. J7 is part of the audio amplifier. very early on when I started on this radio. I can hardly remember any of this stuff. High volume, no control. I don't even remember that. High hum, audio in AVC. My conclusion, AVC not working. Way early on. This is long before I knew all the weirdness in this radio. So insensitivity in the very front end of the radio, going into the IF on all bands. So either due to one of the two first tubes. So either due to the 6K7, which tested good, or the 6A8, which tested a little low. 6A8. I'm going to see if I've got a replacement for that tube, and I'm going to retest it, and I'll replace it and see if we can get something out of that. Okay, here we go. The only place I got left in my shop is the floor. So here's the 6A8 out of the radio. Check the settings here very quickly. 6A8, 6.3, 1, 20L, 27345, 27345, 4610, 4610, 32, C. So this is a different tube tester from what I tested this tube on last time around. So this tube tester is going to do one test on this two-part tube. My other tube tester did separate tests. So it's going to test both parts at the same time. And the expected reading is 750. 750, somewhere around here. I don't think I plugged in. Not plugged in. I'm not plugged in. I'm going to get too far without plugging it in here. There we go. In the meantime, I have all these replacements. These are all 6A8 tubes. Okay, short test. Watch the meter now. There's no light on this one. It's the meter. No shorts indicated. Okay, the proper test is going to be the GM test. Way above 750. Way above. Well, through the magic of video, 24 hours has gone by. When I was testing this tube, which tested okay, my computer hard drive got full. So I had to deal with that. My wife came down and said, hey, let's go for a drive. And that ended up with me not getting back in here until now. But here's what we did on our drive. We went to see a waterfall called Bala Falls. I'll just show you a quick clip here. I'll make a video of our trip because we also went to another area called the Barron's Dark Sky Observatory area. And I took some video there. So I'll put a little video together, but here's a quick shot of Bala Falls.